Sorry. Thank you as well. You have a good day.
Yeah, thank you.
So how do I share this thing? Share.
Oh, Pete, that was an excellent one. This thing right here is just, look at all these little vortices swirling around.
Yeah.
Just beautiful.
Today might not work out.
Yeah, for sure. You gotta wait for that to come across.
I was just looking at it.
So I mean, are you around? I could come right back after that.
I should really be more prepared for getting all this stuff out.
If that works, just stop by your office. Thanks. Perfect.
It's been a very active Pacific. Little storms.
Changed up.
Yeah, a little. Most of that cyclones are.
They wouldn't be little if you were out there.
I feel like it's-
Yeah, like watch this one. I think this is the one that's well controlled. Look at this.
Exactly, that's what you want.
It's just unbelievable how many-
Yeah, that's what I figured out. I like that.
Well, maybe it's the next one.
Yeah. I've been there. It depends on the vehicle. It's like a church. You have to check.
Oh, it must be this one.
Yeah.
Yeah, look at that.
Oh, yeah.
And that is really cool.
Decisions.
So many of them, diamond dozen swirls.
Nor needed.
Well, you guys go all hog wild about your eye wall replacement
Oh, very
stuff. That's just one thing.
Oh, I didn't do that.
Yes. Well, I have to care on Monday. James will be good time.
Okay.
Radiation. I do care. I'm only kidding you. As you know.
Yeah. No, I'm not. They're small and insignificant.
It was a long
As
line.
soon as I get
I
this
wonder what it's like to be out at sea,
link out
see
there.
some of these things and feel them, come in sequence
20 people ahead of me.
like that in that.
Oh,
storm.
yeah. I wonder if they're so small that you
So
wouldn't,
I wonder.
they wouldn't
Yeah.
project down.
Yeah.
I don't know. It's a jar of water.
Wisco Rican is amazing. Yeah, he's good. He's starting up on Monday. He's coming back the 29th. Monday he'll be back.
Like that meal jar.
Yeah,
Was it there for Angel's interview? You know?
I can't recall.
About ready to go, I think.
Yeah, one second. Let me get this shared to the alumni and then I'll be ready.
That was sometime in December.
Share to the
Share as me. Share it. See, this stuff I should have had set up ahead of time. Share to the page.
Yeah.
Made a Puerto Rican restaurant, yeah.
Share the group.
Like everyone I know that.
Oh, excellent.
So much talk a bit about the short term. I didn't get to get much longer.
That's okay. Not really anything. Not for us.
Send out a
East
email.
Coast looks like they're-
There's a 9:33 millibar low at day 6 of the North Atlantic. Deepens, how many? 54 millibars and 18
That's not bad.
in the forecast. Yeah, rather sluggish compared to the rest of
I heard about it great.
Diamond dozen. Yeah.
I was actually more than Myers.
All right, I just sent a link out, so if you want to forward it to Luke, it should be there momentarily.
Kind of busy. There's a
Yeah.
couple people out of town, but I told him.
Okay.
He's not.
John, I
Okay.
Usually
When I come over here, I'll
Yeah.
I'll have you.
so I'll share lower this thing too.
Okay, thanks, Pete, for getting it all set up.
Thank you,
Welcome
too.
to our weekly weather discussion. We do
Yeah,
this every
that's-
Friday from about 12:15 to approximately 1 o'clock, depending on how exciting or unexciting the weather might be. Usually by that time, the weather in the future, but not always. As veterans know, we sometimes get into arguments about things that are entirely focused on the current weather or entirely focused on what happened 3 days ago. So it's very informal and unstructured in terms of how it repeats every week. So, but it's really fun to come here and invariably we start talking about issues at a level that's right at the level of current research in various groups of the department. So it's a great way, especially I got a couple of people in the intro class interested to come in. I think it's great that you're doing that. You get a sense of what we do in this field, at least one sliver of what we do in this field. And if that excites you, then there's a vast horizon ahead. And that's always nice to know. Okay, so Pete's still working on getting people alerted to the fact that we're starting our discussion, and he often loads up a week-long animation from, this time it's GO 17, I think. And very often, this annoys me because it sort of suggests to me how I should begin my discussion. But not today, because it's so interesting. And I was pointing out with this particular storm, I think, how many small-scale vortices there are in there. So I like the idea that this is running as people are coming in, because it should prompt discussion. We have some other things to talk about today that I'd rather get to, but it's been an active week in the Northeast Pacific Ocean. None of these storms are the classic gigantic cyclones that you sometimes get there that get down to 950 millibars. But there's a whole bunch of really interesting little swirlies. There's even, someone noticed this in class today, there's even anticyclonic motion in the clouds, which is not always, you don't always see that. Sometimes it gets disguised by the subsidence. So it's really nice to see a whole bunch of different things going on here in the Northeast Pacific Basin.
So John,
Yeah.
your intro kind of prompts maybe an obvious question, at least to me, is why aren't we seeing these large cyclones in the North Pacific? And this is about the time of year we should be seeing them.
Yeah. Well, I think they're more common in November, late October, all the way to about the end of December. So this might be a time when they start to, though I can't say I know this for sure, I wonder if they don't start to have a little bit smaller scale and therefore less of a large upper level structure to them. But I don't know if that's true. Why I'm saying that, we're getting to the end of January. This is when the jet is at its strongest across the Pacific. So that probably means it's harder for disturbances to unfold in the exit region. And the exit region is really far to the east as far as it goes climatologically, even though it does kind of pulse back and forth longitudinally. It's at its furthest climatological extent by about this time of year. So that might be a factor. I don't know if that's the factor. It probably also has something to do with upstream stuff over North Asia. Is there a lot of seed disturbances that make their way into the jet, or are they coming right off the continent and spinning up at high latitude? There's another beautiful one. Isn't it right at the dateline? And again, just collapses into all these little vortices. So I don't know. That's a very good question. I don't know it off the top of my head. Okay, let's go to our more proximate, both time and space. We'll look at the continental U.S. map. And Pete, I was only kidding about the annoyance. I just said it for effect. And it had none, so I won't say it
We're
again.
looking for North American,
Yeah,
I have listening to you, infrared, right?
well, I'm used to that too. No, I'd rather have the visible at this time of day. We can see a lot in over continental America.
And I'm guessing you want the black and white visible, even though the
Definitely.
color one is cool.
You know, it's cool, but it's not informative.
I disagree.
I know.
Maybe we should turn that light off.
Oh, yeah.
Someone closest to the door. There we go.
I told you, didn't I? There'd be fights.
No, I haven't even started.
This is the beginning.
Okay. So here's yeah, that's right. Oh my God. Baseball, a whole other issue, especially now. Here's our cyclone centered at upper levels over in southern Illinois. And it's really interesting looking in the visible satellite picture. It's got a fairly substantial cloud swath. Much of it's low clouds, and that's kind of what we're under right now, with a few exceptions of something higher. Most of these places where the clouds are a little bit higher are places where we'll see some reflectivity. So it's like they're seeding the low-level stratus or stratocumulus. And then there's much more substantial precipitation rates going on here in the eastern portion of the storm. Not uncommonly the case, but some splotches I think we'll see in the radar of 55 or higher dBz in parts of Ohio and the border of Ohio and Indiana. So pretty interesting day there, but I don't think too windy, and I don't know if there's anything severe that's going on there. It's just rather intense thunderstorm activity. We can't really see on this limited perspective. If we go to the, can we go to the full disk, Pete, from GO 16? You can see a really big cyclone just about to make, I guess, island fall over the British Isles. Yeah, that's a pretty intense looking storm. And I went over to the Pivotal weather site to get an idea of what the actual sea level pressure minimum was in there. It's only in the 970s or something, high 970s. So for those without experience, 1,010 millibars is about the standard sea level pressure. So that's, about a 4% reduction from normal. And it's characterized, I think, safely as a robust cyclone, but nothing like the kind that are in the immediate forecast in that area. They're going to get way down below that. More intense than most tropical cyclones, if not all, on one of these storms.
Well, speaking of tropical cyclones,
That was
speaking of those, what caught my attention was just off to the southeast of Brazil, that cloud head that's
Right
emerging there. You can see the cyclonic turning to the cloud head. This is the area of the geographic portion of the South Atlantic this time of year, maybe a little bit earlier, that we've seen or actually a little bit later in the season, so more into February and March, that we get these extratropical cyclones that make a brief transition
Oh, yeah.
in the last decade or so to tropical cyclones. So it's something to watch. I'm not making any statement about that. I don't think it's necessarily the right look to it, but I also haven't done any diagnostics on it, but it just caught my eye as something pretty impressive.
And speaking of that, if that is the mechanism by which southern hemisphere storms off the coast of Brazil, and cyclonic, interesting, isn't it? Clockwise rotation down there. But is that the mechanism by which they transition to tropical for even a brief time? It must mean the water temperature is warmer than it used to be, right?
Perhaps, yeah.
Because I
think
would
that's
think
probably-
that there's not really a new storm track.
Right, it's that, and also only in recent years has the people begun to look at these disturbances that have this almost an eye-like structure and has sort of a very obvious tropical cyclone-looking structure. Brazil likes to pride itself as one of the big tropical nations in the tropics and subtropics that didn't get tropical cyclones. They didn't call them that.
Yeah, yeah.
And so
Oh, man.
there's interesting issues there about just the culture of naming these.
Yeah.
May I ask a question?
Yeah.
So the term tropical cyclone, et cetera, refers to cyclones that are occurring in the tropical areas, which is all about how much more humidity there is close to the equator, how much more humidity there is in the air, obviously, because of it being near the equator, close over water, et cetera. And then why do you think Brazil would not say this, we're experiencing tropical cyclones?
Okay, so-
Aside from a cultural thing.
Right, so I think culture in the sense that having this history of not having named cyclones in the South Atlantic for a long period of time.
Okay.
About a decade ago, they had what was considered one of the first named ones. But then people began looking back and saying, we've seen some things in the satellite era that are in that position that could have been named but weren't named.
Oh.
And there seemed to be a reluctance just because of tourism, frankly. That's the cultural
Yeah,
part
right,
of
you
it.
don't push
They didn't want
Right.
to, say, oh, we got tropical cyclones on there.
Sorry.
Yeah. No, that's
And
a great
importantly,
question.
tropical storms, it's not only a function of where they form, it's the nature of them. They're different from these extratropical ones. These are very different types of storms than a typical hurricane in terms of their structure and their intensity, how they're put together and all that. So
I don't think
that's
any of
another
the-
part of the story.
Tropical storms that have formed over the South Atlantic have been tropical by the Bob Hart definition.
I
And
thought
they're all
that-
subtropical.
I thought that first one was.
No,
Oh,
they're subtropical.
Okay. So they're almost whistleblower storms, but not.
They're kind of like the neuter canes they used to call them, that form in the
Right.
Atlantic.
Yeah, in November.
In November.
Yeah.
Yeah. It's kind of like what they
Okay.
For those
Okay.
of you who are new to Weather Watch too, by the way, this is not a lecture. We're open to, if you see something interesting or you have a question, shout it out.
Okay, I have another question.
Sure.
So the use of the word cyclonic to the non-weather oriented sort of person seems huge weather event. And yet these cyclonic counterclockwise air currents that we're seeing, those aren't huge, destructive the way I think.
No,
the way
that's
I
right.
think of it.
I
So
would, that's
tell
right.
me- And again, I apologize for taking.
No, this is
No,
not,
sorry,
this is
Mark.
appropriate.
In Iowa, at least, the word cyclones means tornadoes.
Yeah.
And so
right.
there, depending on where you live, there's a connotation for the word
Okay.
cyclone or any
Okay.
derivative of it that means serious.
Right.
In our science, cyclone or cyclonic means spinning in the same direction as the Earth's pole in the hemisphere in which you're looking.
Thank you.
So you're right, there's a need sometimes, depending on where you are, to divorce that colloquial meaning. And nobody likes the Iowa cyclones anyway.
And I think
Is that Iowa State?
Yeah.
Right.
Well, I
Iowa
was-
was-
in Australia, they refer to them as cyclones, these tropical cyclones as cyclones.
Yeah, that's right, yeah.
Cyclone, whatever the name they give it. So it's,
It's all over the map.
in our science, we call anything that revolves, as John said, with the same direction as the pole in the hemisphere that you're in as a cyclone.
And sometimes the mid-latitude cyclones do become strong and do cause a lot of damage on a much larger
Well,
scale than
I'd
you
say
expect
that's
from a tornado.
routinely the case, yeah.
We should move on.
Yeah,
We'll talk about
Okay,
that.
so let's go to the West Coast satellite image. We just looked over the continental US. Let's do the continental US again, Pete. I kind of have this diversion to Atlantic. I just want to have one quick comment about what we're seeing here over us. And I think that is that this disturbance, as we'll see when we look at the upper level charts, is not unlike the cutoff type disturbances that sometimes plague us at Memorial Day. They hang around for a few days, they keep the sky cloudy, and they have a constant threat of light precipitation. Sometimes in Memorial Day time of year, it'll be more likely heavy showers, but not so much this time. So that's something that's going to be part of the forecast.
Right, and part of that's, there are two aspects of this that are really interesting. One, for the first time in a long time, I see your treble clef structure, the PD,
Yes,
associated with
that's
this,
right.
which is something I haven't seen in a while.
Yeah.
And the other is that, yeah, these low clouds are the result of, the cyclone itself is pretty much spun up as much as, it's going to deepen a little bit more, but it's this large scale cyclonic, this counterclockwise circulation above the surface with sufficient moisture that you're getting this sort of Ekman pumping and this gradual ascent that
Yeah.
produces that very light precipitation. But we'll see in the forecast, there's going to be a configuration of winds and isotropes that are going to favor a band of moderate precipitation to develop over us as that upper trough moves toward us.
Oh, exciting, glad to know that. So, yeah, it's a setting in which one can expect prolonged unsettled weather and until and unless one sees signals that you'll show us about. You don't have to have an expectation for severe unsettled weather, but there might be some more high impact weather coming. Okay, and then let's quickly go to the West Coast and we'll go to the upper level charts, and I want to say one last thing after that. Dealer's choice, Pete, whatever you want.
Oh, radar and surface too, right?
Yeah, I did the radar. Did you do the radar?
I'm gonna do
Oh, I did.
my
Okay, I'm
for the
thinking
West
about my
Coast,
class. Okay,
'cause it's
so here's the
mostly
infrared satellite image in color over the west coast of the United States, and one can still see it's an active time. Here's a little swirly well south of Kodiak Island. Here's another one just sitting there in the immediate coastline of the Kenai Peninsula. You can't really see the storm that was off the coast or off the limb here at about the date line. That's an impressive storm as well. Fairly inactive tropical convective line all the way across. Here's Hawaii, so this is about 15 degrees. The intertropical convergence zone is not as active as one sometimes sees it in this portion of the hemisphere, and that's interesting. Though it does seem to also, in this one portion where it's active, does seem to send some water vapor and high clouds anyway northward towards Baja California. But a rather limited forward excursion for this time of year. One often sees occasionally gigantic plumes of water vapor moving straight forward towards the west coast of the United States. This is a couple of weeks ahead of the big World Surfing Championships, King Kamehameha Surfing Championships. Now, the reason I bring it up is because when you have an active Pacific storm track at the end of an elongated jet, you can send a lot of wave activity toward the Hawaiian Islands. This does not look like a particularly, because the scale of the storms is small, doesn't look like a particularly robust year for that. So I wonder if they notice interannual variability of the waves during that championship. And it would be directly related to storm activity well to the north and sometimes northwest. So anyway, I wonder about that. Okay, so let's go to the radar depiction across the continental U.S. And one thing that stands out to me in this is the obvious difference in reflectivity ability of liquid precipitation or rain-coated pieces of ice and those that have no water on them at all. You can't really depend on very good reflectivity from snowflakes, and you get much better reflectivity off of at least raindrops or ice coated with rain. And occasionally you see a couple of spots where you get up to the about 50 to 55 dB sea level in southern Ohio and parts of the border, Ohio and Indiana. But they're not long lasting. They don't look particularly well organized and probably don't present much of a severe weather threat. But nonetheless, you'll hear a rumble in southwest or southeast of Fort Wayne in the last hour or so that you might not expect in late January. And then here's the very light snow that's apparently on the western side of the storm. As Michael said, he mentioned something about the occluded structure and work that I'd done some years ago, but trying to understand the structure of the occlusions all the way to the tropopause above and seeing how the precipitations kind of fit into them. And it really does look like a really nice case of a deeply occluded, well-round up system. And characteristically on the northwest side of it is where they do have snow. Sometimes very heavy snow, not this time. Although not right now at this time. There may be some genetic activity later on that improves the chances for that. Widespread showers over the Pacific Northwest. This is probably, I'm going to guess, this is just cold air. I'll guess it's about minus 30 or so at 500 millibars over the Puget Sound. Let's see if that's right. And I'm basing that on the spacing between cells as they come on shore. The bigger the spacing, the more intense the convective towers, and that means it has to be colder a lot. So you can actually, I'm sure machine learning people or machines themselves could figure out an exact relationship, and it would be more than just my recollection. And here's some other cells over northern Nevada and southwest Idaho, and not much happening over California, except for some sort of radar conflagration south of Chico. I don't know what that's all about, but probably not precipitation. Okay, let's take a look at the 500 millibond map.
You do surface.
Surface map. Yeah, I'm out of practice.
We're all out of practice.
So here's our surface map. And I like it unadorned with analyses because you can kind of zero in on the actual observations. Many people were in Boston when it was 74 degrees not long ago, and now it's 48. Even that is 15 degrees above normal or more. So it's been an incredibly warm winter for them. They haven't really had a bout of any kind of cold. We have light rain, 34 over 33. The dew point being above freezing means, at least for the time being, we're not going to see any of this turn to snow. It's just impossible to maintain a piece of ice in dew points that are 33. It's not going to happen. Snowing in southeastern Minnesota, not at Minneapolis. So you can see, as it seemed on the satellite and the radar, the precipitation is light, and though fairly widespread in the regions where we saw the reflectivity, and then light snow also. In places where light snow engenders a little more concern, southwest Missouri, they don't see it as frequently as we do, so it might get them a little bit more nervous. Down in the southern United States, we're dealing with, we're on the eastern side of the storm. We had more intense reflectivity, a couple of places here. That's not Columbus, it's to the east of Columbus. Moderate rain. Light rain prevails in most of the observations on the map, and there's heavy rain here in far western South Carolina near the mountains. But only a few spots of moderate rain that we see. Here's another one down near Cincinnati, not quite Cincinnati. So a few of those places with high reflectivity are, of course, showing up in the observations as moderate rain, but nothing else. No one's putting thunder on the observation. There's light winds only, so it's not really a severe event. It's just a heavy rain event locally and temporarily.
We could look at the lightning map to see if there's any.
Oh, yeah. I'm going to make a guess. I'd be surprised if there's very much, but let's see. That's weird.
Striking.
Striking. Shocking. One could even say.
Some would say.
Wow.
Only out in Nevada. That's
And down here,
really over the east. Yeah.
yeah, did we see any at all?
No strikes.
Yeah, wow, okay, so that's even more evidence that it's not even slightly severe. There's nothing like that. So no rumbles of thunder in Fort Wayne, as I thought, I said earlier. And then let's go to the southwest, and one can see a pretty decent day across much of the southwestern states, including Texas. Clear skies, temperatures in the low 60s, sometimes higher if you go further south. Same in the higher elevations of parts of New Mexico and Arizona. It's a little cooler at high elevation. Flagstaff's 43, Tucson 60, of course, but a nice day overall everywhere. And then on the west coast, we saw intermittent showers in parts of the state of Idaho. We also saw some over Washington, so they're coming in and out, and they're kind of missing at this particular moment any of the observing sites that are reported on this map. Yes, there's some light snow, and is that Pocatello or Boise? I forget which one's where. And then some light snow in the Aryan homeland as well, up in the northern part of the state. So,
Hey, John,
yeah,
I can't see very well, but is it really in California? Does it almost look like an atmospheric river on the satellite?
it was well to the south. It looked to me like it might be something like it, but a weak version over Baja California. There's no rain reported anywhere on in these observations. No.
Hazy fog.
Yeah, haze.
What was interesting is we saw the lightning strikes in Nevada, but
It's pretty central. It's probably just missed.
yeah, maybe
it.
missed in that.
Yeah.
Wait, why was Nevada the only state that showed lightning strikes?
Not sure. We're suspecting it might be something in the eastern United States, but when we looked at the lightning map for the activity, there was some lightning over central Nevada, but it's not showing up. We may be missing it.
Yeah.
between
Yeah.
stations there.
There's a lot of space between those
Would
observations.
just be the convective storms in the mountains.
Yeah.
Yeah.
Right.
It's a jet exit region there.
And they're bound to have ice in the clouds too, so there's more chance that you're going to develop charge separation and whatnot. But we might see now when we go to the upper level charts if we have some sense of what might be generating that unusual, not unusual, but noteworthy.
The air doesn't have to be conditionally unstable, it has to be potentially conditionally unstable. So if you lift it in the mountains, it becomes conditionally unstable. It's just in that little area over the mountains. See, they have
A little trough too.
Yeah, so there's a little bit of a weather maker in the north, western part of the state right near Lake Tahoe, and that's probably enough to trigger some of that stuff. And the whole trough axis extends along the Pacific West Coast. Weak though it is, it certainly does have some, relationship to the showers we saw moving across the Puget Sound, also Idaho and parts of Oregon. So that's related to that. Here's a beautiful upper level cutoff disturbance that's at the heart of the weather we're experiencing. Remember we saw on the satellite that it seemed to be pivoting around southern Illinois. That's about exactly what the 7 a.m. observations some hours ago now would have suggested, although not exactly in that spot. So I'm guessing if we had current obs at 500 millibars, we have our trough displaced slightly to the north and east. It's negatively tilted. The characteristic that catches my eye is the utter lack of baroclinicity on the whole northern half of the storm. Maybe with the exception of the western portion, there's a little bit of temperature contrast. There's almost none in this entire region of the storm at this level. Now, that's partly somewhat to be expected. You'll see at other levels below this, there isn't very much at all. And there's a weak but discernible region of decent horizontal temperature contrast, sort of like an upper front back on the northwest side, southwest side.
Yeah, I'm just trying to get the contour. It looks like that's maybe 20 degrees of contrast and or 15.
Here we got minus 28 at Little Rock and minus 16 well down the coast of Victoria. So that's only 12.
Over Kansas.
Kansas? So minus 25 and it's about minus 18 in
Okay, it's
Amarillo.
only
So
7.
it's not very much. Yeah, it's like there's a little bit of a pocket in one of those isochrones. I hate how they're drawn.
Oh, yeah, okay, see, I
don't think there's 3 different
Right.
isochrones.
You're right.
So it's pretty weak, and that's one of the things that certainly differentiates this from a storm very much like this one, 19th of January 1995, where we had 14 inches of snow. We're in the right place for it, and you can see that. A really nice deformation zone. Here's the axis of dilatation of it, and so we should be on the warm air side with the air rising in weak to moderate frontogenesis aloft. There's just no temperature contrast. You can't do anything with it. It's minus 21 in Cincinnati. It's minus 22 in Minneapolis. There's no way to make that gradient stronger, but there isn't a gradient. So that's too bad. But the presence of this upper cutoff, where the temperature gets to about minus 30, that's what reminds me so much of the cutoffs we experience sometimes in the mid to late spring. They can ruin the weather for a period of time because they don't really move very fast. There's nothing that apparently connects this cutoff disturbance to the prevailing westerlies at much higher latitude. We'll probably see that's true at other levels as well. So it's going to sit here and just spin down to its death or gradually get reabsorbed on a trajectory to the north and east. And then either one will take time.
Well, I want to point out that this is an extremely progressive pattern right now. It's you look around the globe and it's almost all westerly everywhere. There's very low amplitude perturbations going forward right now compared to what normally you see a ridge somewhere blocking ground.
Definitely true.
This is just zonal everywhere.
Yeah, in fact, the next place I wanted to go was 300 millibars. And that'll illustrate that. And it'll prompt questions that we can address by going somewhere else. So, trying to take into account the limited area and the projection that's used, Greg's point is extremely well taken. Here is what looks like effectively a westerly jet. Here's a west-east longitude line, a latitude line. This is a west-east jet that crashes into the coast. It picks up another effectively west-east portion of the flow with our upper trough over the central U.S. And then maybe this is a little bit of a subtropical feature that comes across the panhandle of Florida. And then this is a polar trough at higher latitude. But there's at 300 millibars in mid-January to see only a few places where the wind speeds are greater than 110 knots is exceptionally rare over this segment of the world. And especially true is the absence of any substantial polar jet structures at high latitude. This one probably is related to a polar jet, but it's really weak.
A little bit like a November pattern.
I didn't even say October. I would say even earlier. Let's see what it looks like at 200, where we know we're above the polar jet climatological elevation, and see what it looks like. Nothing at high latitude. There's no wind speed maxima. The gray shading is shaded first at 70 knots or greater. That's not really that much. And so all we have is this feature off the west coast. This is the subtropical jet, more obviously shown at 200 millibars. But even it is just boring and flabby. Look at this, 70 overall this region. A little pocket over Florida that's maybe 90-ish. And then nothing else at high latitude. And, well, it's the wrong level to comment on this. I'll go to another one. I'm going to say later on, very little baroclinicity, though this is a bad level.
But one thing I want to point out, at the same time, if you look at globally. The southern hemisphere is extremely active for this time of year.
Yeah,
In the southern hemisphere, the jet streams down there by Antarctica, it's their summer, and yet they look pretty, almost like it's their fall.
wow, that's interesting, yeah. So this is a really weird winter, and I'll have a comment about the weirdness of the winter that goes beyond just the recent few days at the end of my portion of the discussion, almost there. Let's go to 850 millivolts peak. In January, we're a week shy of the coldest day ever recorded in Madison. And we're just about at the peak, as you'll see in a minute, of how cold it gets in the northern hemisphere. It happens the first few days of February every year. This is 850 millivolts, and of course, the western US is below that level, so this mass of red and attempted isotherm analysis is terrible. But if you go everywhere to the east of that pointer line, you see that it's really hard to find any really strong horizontal temperature contrast. And the way that we measure that, people haven't done it before, is spacing between successive red lines, which are isotherms. On this eastern portion of this cutoff low in the lower troposphere, extends all the way down there, there's almost no horizontal temperature contrast. It's +2 at Nashville, it's -4 at Green Bay. That's a May time temperature contrast, maybe early June. There's just nothing to this disturbance. And so it's not surprising that it's drippy. Greg and I were talking about it today when I was at the bus stop and we saw each other for the first time today. He said, this looks like, what did you say? You thought it was like November?
Yeah.
And I thought more like February because it's gloomy. There's a little bit of snow on the ground, but it's melting as it's falling. It's miserable. So either one is far away from the extreme
You
point
tend
of
to
the season where we
be
should.
lax in shoveling the snow.
Yeah, because you know it'll melt.
It's just gonna melt.
You know it'll melt. Yeah, that's right. That's what you said. Yeah, that's exactly right. And so it's just a really flabby, poorly put together storm. And the thing that caught my eye is that if you look, at least in this limited domain, that's true of every one of these storms. This thing has very little variability. It's fairly intense. This one has very little. This one up here over Hudson Bay has, or north of Hudson Bay, Labrador Sea has very little. So it just looks like we're in a period, an unusual one, for late January, where the horizontal variability is pretty weak over parts of the western hemisphere, even in the lower troposphere. And the -5 isotherm is way up here, it's right here. Right here, most of the continental United States is warmer than -5 degrees C at 850 millivolts, which is exceptionally unusual for this time of year.
It also
Contributes to something else.
I'll submit to this, the reason why is the tropics are not sending plumes into the northern hemisphere. There's nothing, they're sending plumes to the south, and the southern hemisphere, they're not sending these perturbations in the northern hemisphere, which release the cold air.
Yeah, so there's nothing to, the idea Greg's had for a long time, it seems right to me, is that and it's related to the idea of a zonal index many, many years ago. The notion that if the flow is more or less zonal in the wintertime hemisphere, then cold air will certainly get generated at high latitude, but it can't find its way southward because there's not enough perturbations along the zonal, the westerly flow that will allow it to make excursions equatorward. And in the absence of doing that, all you're going to do is make it colder at very high latitudes and never send it southward. And we're in a period right now where that's definitely.
Well, however, along with this, 850 is not that cold. So, I mean, it's
Until you get
colder at high
fine off.
latitudes, but
Yeah.
it's not cold like it gets. I think the cold air is sitting on the ground.
Okay.
Below 850, I think the cold air is just laid out over the ground at the high latitudes, and it's not in play.
It might be true. I haven't looked at surface off, but I've looked at the 850 extensively, so that's interesting.
So I haven't been keeping up with things.
Yeah.
Is there any relation to what's been going on to stratospheric?
There
Like,
has to be.
Has there been a weird stratosphere these last couple of months?
That I wish I knew. There has to be a relationship. What if the polar night jet is weakening
It's
Or
strong.
strength.
The polar night jet is very strong
If
right
it's
now,
strong,
very symmetric.
and it's impenetrable to, well, it's not impenetrable, but it's waiting for, Greg's idea is it's waiting for excursions poleward from the subtropics that will perturb it and then set some waves off in it and then send the cold air southward with those waves. And in the absence of those plumes from the subtropics, then it just revs itself up and it's really strong and
It's
it
just,
contains
it's
the
up
cold
real
air.
high, it's not interacting with the surface. And the surface, the cold air is just laying in the ground. It's not deep enough to be in play. It's just friction's holding it up.
Yeah, it's really interesting. So I want to end with, well, my part of the conversation with something from my own computer here, Pete, so we can just kind of switch them. Yes, they just go right up here. So I've been keeping track of things related to this, the 850 millibar air colder than -5. So 850 millibars is about a mile above sea level. -5 is a reasonable temperature to, I guess, it's the only one, but it caught my eye because it's really good for rain, snow division in a storm. So it had some pointage for me. This is the warmest December, January, and February in the 72-year NCEP reanalysis ever. Yeah, this is the warmest year, 2014-15. So what I want to show you on this chart is the following. The solid blue line is the daily, here's the days of the winter. The daily average aerial extent of air is cold as -5 degrees C or colder over the northern hemisphere. And then plus and minus 1 standard deviation above or below that average. And then the red line is the daily time series from that winter. So as I mentioned earlier, here we are about January 24th. We are just shy of the peak of the coldest day of the year. By this weird measure, how much area is there encompassed by -5 air over the northern hemisphere? That's about February 1st. Here's the time series from that warmest year ever. And how do I determine it's warmest? I just add up the departure on every day from average to the actual date's value, and then add them all up. So it's just a simple addition problem. And then this one has the largest negative value of all time. Right now, comparing this year, 2014-15, to our current year, up to the 22nd of January, we're second place still. This is still number one, but we're in second place all time. So we have almost a record warm winter going. Now, the reason I want to show you this is, look at what happened here. We flirted with average in late December and early January in that year, and then suddenly went way down to places we've never seen before. It's like the Hades of cold air in mid-January. 60 million square kilometers, it should be something like 71 or 2. Okay. So we're way down here, and then there was an attempt to recover. Let me show you what this year's time series looks like up to this point. So that's this same average and plus and minus 1 standard deviation. We started out a lot worse. So for a long time, through the end of December, we had the warmest December of all time by this measure, and we had the warmest year until we got to this average point, just about time of AMS. One excursion above the average for the calendar day, and then this precipitous drop in the last 4 or 5 days that gets us to the 22nd of January. This is currently the second warmest year of all time. Let's superimpose it to the next slide. Wow. Something really different about mid-January between these 2 years would be an interesting thing to look at. Because otherwise, they're kind of competing with each other for the warmest year of all time. The reason why suddenly 14-15 goes wild is because something happened. This is a hemispheric measure. So it's not just that it got really warm over the British Isles. That's not sufficient to make this difference. So I'm kind of thinking this 10-day period might be really interesting as a comparison between these 2 years, no matter what happens next. And it's simple-minded enough that I can even undertake. So that's what I wanted to show
If you're
you.
to look spatially at the extent of the -5 degree isotherm, on the winters where you have this very well below normal.
Yeah.
Are those, is the extent largely confined to just over the continents and not over the oceans?
I don't know if I have the answer to that question. I have the answer to a question that's related to it, and that is when it's the opposite. I looked at both extreme warm years and extreme cold years. And extreme warm days are days like this star day and this one here. I haven't done it yet for this year. They are at least 2 standard deviations on the calendar day from the daily average. So those are days that count. There's probably several other ones. I just highlighted a few of them.
So I have a partial answer for you in 2014, 2015, that winter, since I've been researching it. You have near record cold anomalies over the ocean of the Atlantic. So my guess is if you count out the Atlantic, it's a good chunk that that's got to be land.
Mm-hmm. And I was going to say, it's probably going to be similar to that answer. I was going to say that, first of all, looking at just the warm days, you see no geographic, over the whole 70-year time series, you have no geographic preference for why is it warm for the hemisphere. Is it because of these places? There's no serious correlation. However, exit region, the Pacific jet, exit region, and the Atlantic jet are the places where the variability is highest. So my guess would be something's different about those places, and that's in line with something about what's going on in the Atlantic Ocean, for at least the Atlantic storm. So, but I don't know any more than that. So. See, Liz, this is what happens at this forum. It's exactly what happens. So anyway, that was what I wanted to leave you with, and I'll turn it over to Michael for the forecast. And let's hope, since it's been such a boring winter, let's hope that we get the record. But we have some work to do, as you can see.
Right. And also just
That's what I would
commented, welcome Professor Maroon to Weather Watch. This is your first, I think, official Weather Watch as a faculty member on our program.
Yeah, that's right.
And so what we're gonna do is go to a site we haven't gone to in quite a while. And this will actually be updated shortly as Isaac begins to get the wharf model up and running. So we're gonna start off with a meteorogram. This is from MM5 run that we've had running more or less constantly for about 20 years. This won't die. And Pete realized it hadn't run since June, but that's a different story. Yesterday we discovered why currency couldn't find it, but it's out there, it's still running. It just comes up by itself when you reboot the computer. But this is showing the temperature trace, dew point, and accumulated precipitation and precipitation rate for the next 60 hours or so. Actually, only not 60 hours. This is actually much shorter. We only ran out to 36 hours for this run. But what you see is a significant precipitation event is forecast over Madison in the next 18 hours or so, next 24 hours or so, beginning later on this afternoon. We can see the temperature. We don't see that full diurnal cycle because we don't have a long enough chart here, but the temperature range here is somewhat muted from what we've typically seen, although we haven't seen this in over 6 months or so, these maps. Temperature and dew point. And so we stay pretty moist in terms of relative humidity, relatively high, above freezing, at least as forecast by this model. And let's take first a look at the time height sections. And so again, just to refamiliarize ourselves with these maps, it's the time height section. It goes from 12Z this morning to 18Z tomorrow afternoon. And the yellow lines are isotropes, so lines of constant potential temperature. Blue, contour here, solid blue lines are omega or minus omega that's plotted. So this is upward vertical motion, ascent, and then in red we have our relative humidity contours, 90, 80, and 70% contours here. And our green line is our friend, the dynamical tropopause, up there just for the measure. And so one of the things that we note in the maps are over the next, if you look at first at the winds that are also plotted here, you know, that's persistent easterly wind we have, fairly deep, moist layer over us. Persist, the winds become more northeasterly overnight and eventually become more westerly, northwesterly by tomorrow afternoon. That's during this period when we see this transition of the winds is when we're also beginning to see an increase in the depth of this moist layer over us, coupled with the ascent that's occurring. And those two together suggest a greater water vapor content. The relative humidity is going up, ascent occurring, which is pretty consistent with the relative humidity going up. Some slight cooling, although you don't really see much of it in the column. That's going to lead to a period of precipitation. And so what's going to be of interest will be rain and will be snow, with temperatures just very close to freezing. I think there's a big contrast in the models with whether or not it's going to be all rain or all snow, but we could be looking up to 3 to 6 inches of snow over the next 24 hours when this burst of precipitation comes in. Let's step back. First, look at the 500 millibar forecast. Again, this is going to be abbreviated. We'll just start off with the 6 hours of the forecast first, please, Pete. So you can see this really well-developed upper trough, that negatively tilted trough that John was referring to earlier. It was over the sort of Blue Hill region of Missouri, and now it's moved into southern Illinois. That's kind of just where we're seeing in the satellite image with the swirl. And really nice looking trough. But again, because of the lack of significant baroclinicity to our north, we weren't expecting much in the way of any sort of significant forcing for ascent or precipitation. If we go to actually look at 700 millibar map with the vertical motions plotted, at the same time, you can see it's just pretty much devoid of any significant upward vertical motion with this. There's this band that's consistent with what we saw in the radar summary of this sort of stratiform, maybe a little bit embedded convection, but not thunderstorms over the eastern part of the United States. The model did a pretty good job of picking up those big features.
We should be getting hammered. This is a really nice setup on a large scale.
Right.
Just no temperature contrast.
Right, so the lack of that baroclinicity, but things are going to change a little bit, or in a modest sense. Let's go ahead to 12 hours on forecast. I put this up below at 500 millibar, please. And you can see it's slowly moving to the northeast. This vorticity maxima is getting a little bit more balled up. Structure looks good. There's even a lobe of vorticity that actually extends out over from Detroit down to northern Indiana. And if we actually go back, we'll do a loop at one point, maybe at the end of this. We'll go back to 6 hours. So let's check where that comes from. It was really pretty stationary, actually amplified a little bit with this spoke of high vorticity, but you'd expect this to have moved off to the northeast, I think, if it would purely be an event. But let's look at the vertical motion pattern at 700 millibars again at this time period. We're beginning to see just down sheer of that vortex strip, this sort of dipole ascent, descent here. Here's that strip of strong vertical motions east of this, perhaps along what may be a cold frontal type structure. If you go to the Q vectors at 700 millibars, not necessarily the best layer to look at 12 hours of the forecast, you can see some regions of Q vector convergence in red just to our southwest. But again, this is not a great map to look at for this particular plot. And I haven't looked at Q vectors in a while, John, but this sort of swirling motion of the Q vectors without much in the way of it's clearly convergence. It's a perennial of this. I'm not sure if you can infer something directly from the wind field. You should be able to do that based on you know what theta is and you know what the Q vectors are for this.
Well, you're everywhere you're rotating the gradient because it's in such a rotation. But you can take the curl of the Q vector and you get something like the vertical derivative of ageostrophic wind or something like that. I can't remember.
Interesting calculation. Okay.
Yeah, it's kind of cool.
Okay. Let's go to 18 hours in the forecast, 500 millibars. Just continue this. And this level of vorticity that's been growing and rotating toward the west, we're going to see, let's look at the surface map at this time. Keep my hand in that region. Okay, we also look at the thickness contours here and the minimum thickness is right along the Indiana-Illinois border. And we have, advection of that vorticity by the thickness field would certainly put us in a region where we're going to be down sheer of the vortex lobe or notch that we saw, the region of ascent. So this model is forecasting an area of precipitation, of light to moderate precipitation, begin developing over the eastern part of the state close to midnight tonight. This is beginning to develop. Thicknesses are cold. This is the 540 line. This is 534. We have to look at some soundings, look at the temperature structure, but this would be probably cold enough for snow in this particular configuration. Let's continue to, let's go back to go to 700 millibar vertical motion at 18 hours again.
Oh, yeah.
We have a vertical motion maximum right over us.
And a couplet because you have a subsidence maximum over
Right.
Michigan.
Yeah, so it's nicely attached to that
Yeah.
vortex structure. Let's go down to the zoomed in maps as well. These are from the 30-kilometer grid. Go to 18 hours in forecast. And you can see this area of precipitation. Here's the 0 degree isotherm. This is when our winds are now turned to the north, so maybe some modest cold advection with this accumulated precipitation. And this is in 3 hours. And we're looking at amounts that are about a quarter of an inch or so. So this will be coming down pretty well just to our east. Again, this is a really, even though this is a 30-kilometer grid, you can see that we're just going to be on the edge of, we're going to be in that gradient of heavy precipitation. So depending on exactly where this sets up, it could all be just to our east, between over Milwaukee and areas, Waukesha, those areas. Things taper off pretty rapidly as you go to the west, on the west of us. So we'll be just on the edge of this. Let's go back a click and go ahead to 21 hours of the forecast. And you can see we're right in that band at this point. So sometime between midnight and 3 a.m. or so, we could be seeing a pretty good snowfall event as this band sort of sets up, as that vortex lobe kind of rotates over us. Let's go to 24 hours in the forecast tomorrow morning, 500 millibars, please. So 24, and we'll wrap things up. You can see by that time, the lobe is pretty much just to our west. This was probably near the ending time for the precipitation as this whole weather system begins to lift out. At the surface, at this point, I'll leave the axis of vorticity over us. There's still in a region where we're sort of down sheer of that, so there's still being some light precipitation occurring over us. So, again, this looks like potential for several inches of snow, a wet snowfall over us by tomorrow morning. If we click this out to with the last frame, let's go to 30 hours in this, because this model work on failed. Things begin to fall apart as the upper trough itself, you can see the thickness scale of the upper trough beginning to move out a little bit with lighter precipitation. But this large scale cyclonic circulation of this moist boundary layers would still favor lots of clouds over us, probably into at least tomorrow evening before things begin to break up on Sunday. if we were to switch this, let's go to Pivotal site for a second and get a quick look at some of the other forecasts. Let's go into zoom in to the continental United States, or regional, please, and then we'll go over to the Midwest, to click over, and go to, let's scroll down to winter weather, and look at 3 different models very quickly. Total cumulative precipitation 10-to-1 ratio. So the GFS forecast will go to 36 hours. So just by the time I think it should all be over.
Oh, all rain.
10-to-1. Yeah, this is giving us about just 0.6 of an inch of snowfall accumulation. Let's go to the 3-kilometer man.
Ooh,
3.2 inches with heavier amounts just to our south and east.
it's just like the MM5 distribution.
Yeah, I mean, M5 was probably would have favored something, some band more like this.
Yeah.
And then, but it's also, it's more snow. And then if we look at the ECWF, which is in, that's not the other, sorry, the high res, so-called high res ECWF. So winter weather.
Can I get regional of that?
I think when you clicked on the other one, it lost the mapping. So total accumulation,
And then you have to go out
let's go to 30 hours, I think, or 36 hours. What did we use before?
36, yeah.
36, about 4.3.
Yeah.
So that's this band of snow. So again, where this sets up is going to be critical, and you really want to wait until later on tonight as the snow begins to fall. You can see that band beginning to rotate back from the east, where it actually lines up, gets stationary for a while before it begins to lift out.
And the temperatures too.
And temperatures are
There's
critical.
probably more, there's recent probably in GFS too, but it was warm that came as rain.
Right, so yeah, let's look at if we go back to surface, let's stick with this, we'll go to surface and precipitation, and look at just total liquid, total accumulated. And so this model is going to be about 0.4 inches. Remember, the MF5 was about 0.4, so let's go to the NAM, that's 0.3. And the GFS,
High res or regular?
I don't know if there's a difference with those two, but
Same.
0.3.
Yeah.
But it suggests maybe it's just a little bit warmer. And we could look at soundings and all that if you wanted to investigate this a bit further. But the GFS seems to keep this more liquid than frozen. So it's going to be a wet snowfall, be kind of a pain to shovel, but it'll nice coming down. I'm sure John will be waking up with a grin on his face as the snow.
Yeah, they have to be 3 a.m. though.
Right.
That's really unusual about this pack. First of all, the precipitation pattern is just off the charts unusual. Just seeing it on the package. But what else is unusual is the subtropical jet right now is running along the Gulf Coast, completely zonal.
Right.
It's not ridging up on the East Coast at all. It's going straight to Africa across.
There's only a slight little angle across the peninsula, but you're right, it's not going crazy like it should.
And so,
I mean, I don't recall ever seeing the subtropical jet go straight across the southern part of North America and head out in the Atlantic.
Didn't we see that in the fall? We talked about that one day, I think. We said, why is this just so zonal over this segment of the Western Hemisphere? But I don't know if that was this year or another year, but it wasn't wintertime. I know.
before we go to that, let's just go to the surface map. I think we're going to see a change in the configuration of that. This will be something to talk about perhaps this year, next week. If we just step ahead to, I know this is getting out to fiction land. Let's go to a week from now. Okay, we're going to be getting
That's a good storm.
a pretty significant storm developing in the Western Gulf. And this, at some levels, reminds me of the March '93 storm.
This is the way they used to happen when I was a boy in
No,
New
that's
England.
right. These are the old-fashioned storms.
Superstorm.
The superstorm. Watch what this happens in this forecast. This is not going to be a super storm. It'll be an interesting storm, but not a super one.
It does look like 93.
93 went off the coast there.
Yeah, that's right.
There's some heavy snow in the
Cleveland Super Bowl.
Shenandoah. And this thing just begins at 988, 198 hours. And again, we get some wind and a little bit of snow on the backside of this, but it's relatively warm.
But
Let's
the reason
stop
it's
this.
not doing anything is because the subtropical jet
Right.
is still not rigid. in it.
But let's look at ECWF same time. High res. It has this sort of amorphous blob in the southeastern part of the United States. So let's just go ahead with this. Maybe it's not going to congeal into anything of interest. 2009. That gets me super excited.
It's just like a phasing event in the
How
European.
things come together. So 2001. It's at a 993, so it becomes a pretty significant storm.
Totally different.
With heavy stuff, but look at it. So it gets down to 986. Again, this is 976. This is really begins to deepen.
God, I can hear Cliff Mass already.
975. This is ECWF. This is not the GFS. But wait,
No, I know, that's why I
know,
can hear it.
but let's just let's stop there. Go to GFS.
Well, wait a minute, go to another forecast, see how stable that ECMWF is.
Well, yeah, we can do that. Okay.
No,
You'll see this. You'll see this. You'll love this, Greg. You'll love this. And let's go to yesterday, 12Z. Because this has been all over the place.
Whoa!
No, you got a 954 here. And we can play this game of changing forecasts. Let's go to 18Z forecast from yesterday. 6 hour difference.
Whoa.
It moves its way out here. But if you go to ECWF, okay, I'll go to 0Z. Let's go to 0Z.
Wow.
There, okay. And,
Threat averted.
but hold on, let's stick with, let's go back to GFS.
Was it just faster?
No, GFS, sorry. I'm sorry. Back to GFS for a second and go back to yesterday, 12Z.
Pete, can't you handle this very simple assignment?
12Z, 240 hours. No, yesterday, 240. Yesterday, 12Z.
What?
Yesterday's 12Z initial condition. Go back a little bit. I'm trying to think of where we have the deep storm off the East Coast.
Oh, there
Okay,
you go.
so you look at this, wow, that looks impressive. If you look at the ECWF initialized at the same time, this goes up to 240 hours. Look at this. Wow. All right. And
That's
then
why I
let's
can hear it.
proceed in the next forecast cycle. Because we valid at the same time, it should move everything along. Bang. So
Yeah.
there's a lot of uncertainty in the forecast. That's
Yeah.
one thing I want to highlight. Well, that's a pretty intense cyclone inland from 0Z run last
Yeah.
night, ECWF. And then the current.
Imagine that, a
12
lot of uncertainty in a 10-day forecast.
Right. Sometimes you nail it, like the superstorm from 93.
Yes.
That was actually a week out, 10 days out. Was actually
That's a real anomaly though. It's
Right.
not the norm.
So when people say, oh, the ECWF is getting the storm sooner than the GFS, well,
Yeah.
GFS actually had it before the ECWF.
Yeah.
Cliff is not going to say anything positive about that.
No, he won't. He'll
I
cherry
should be saying that. But we appreciate all those comments from everyone.
Yes.
Anyway, so a lot of uncertainty, but this is probably something that will be talked about next week and probably 2 weather watches from now if we do get that development in the Northern Gulf. Really interesting storm.
Yeah.
And lots of aspects of it. What's driving, what's changing the structure, perhaps with the tropical jet, the wave that initially triggers this. It's all going to be really interesting.
I think that's what it is, I'm pretty sure it's a subtropical jet that's missing in some of these and appearing in others.
So lots, of room for an analysis for this particular storm. But anyway, welcome everyone back from our break and back into Weather Watch. And we'll continue through the semester. Please, if you're available, particularly grad students or even undergrads, and certainly those that have taken 452 or taking 453, come on up.
Yeah.
And lead some of these discussions. We greatly appreciate it. But thank you, John. Thank you, Pete. Thank
Thanks,
you, everyone,
Pete.
for
Thanks,
questions.
Michael.
Yeah.
And see you next year.
Thanks, Pete.
You bet.
Your big bucks.
I don't think so, because I got class at 12.
Cody